Let's tackle a problem from section 8.1 in Rogowski's calculus book. This one is on arc length. We can take problem 9 on page 448. Here's what it says. Calculate the arc length over the given interval, y equals 1/4 x squared minus a half natural log of x, and the interval is from 1 to 2e. So let's see what we have here. Take the liberty of writing the problem down. Okay, so remember arc length is, if you're thinking about that, it's derived from the Pythagorean theorem approximating each piece. So what we have is we have the integral from a to b of the square root of 1 plus the derivative of the function squared. So what's the derivative of this function? Well, x squared, that's 2x, so we get 1/2 x. The derivative of this is minus 1/2, and then this is x to the minus 1. Makes it a little interesting. And then dx, because we're moving along the x-axis. Okay, so this is actually a pretty common problem form with arc length problems. What happens is sometimes these are just too complicated to actually integrate, so often just to test your skill, what they do is they give something that has kind of a cute algebraic simplification. So this is one of those cute algebraic simplifications you should keep your eye on. When you square this, you square the first term, it becomes 1/4 x squared. The middle term, 1/4 times a fourth, x times x inverse, becomes a constant. That's, I said 1/2 times 1/2 is a fourth, but you get 2 of those, so it's minus a half for the middle term, and the x and x inverse cancel. The last term is plus 1/4 x to the negative 2. So can you see that what happens if you put together a 1 and a negative a half, you get a positive half. So if you were going to write out the same thing again, you'd write out basically the very same piece, except for you have 1/4 x squared plus 1/2 plus 1/4 x to the negative 2 dx. Well, isn't it convenient? I actually know how to compress this into a squared. I did it right up here, only here it had a negative. This piece in here is a perfect square. So this in here is actually the square 1/2 x plus 1/2 x to the negative 1 squared. So that's the algebraic trick. You might sort of pause and double check that you believe that. And the nice thing about that is because it's squared and square rooted, those cancel. Now you just have 1/2 x plus 1/2 x to the negative 1. That's pretty easy to integrate. So without the square root and the squared, it's pretty easy to integrate. 1/2 x integrates to 1/4 x squared. 1/2 x inverse integrates to 1/2 natural log of the absolute value of x. Because both my endpoints are positive, you can drop the absolute value if you want. So now we're going to evaluate at those points. So 1/4 2e squared. So what is that times 4e squared? If I actually multiply it out, plus 1/2 natural log of 2e minus, plugging in a 1 here, 1/4 minus 1/2 natural log of 1. No, the natural log of 1 is, of course, 0, so we can kill that. These cancel, so I get e squared. Let's see, if you wanted to, you could probably leave it here, but this actually separates using the log properties. We get 1/2 natural log of 2 plus 1/2 natural log of e. Now, natural log of e, of course, is 1 minus 1/4. So I have half minus 1/4. So probably the simplest form is e squared plus 1/2 natural log of 2 plus 1/4. There you have it.